Welcome to today's geography lesson. My name is Rina van Meerden and this lesson is brought to you by the Gauteng Department of Education in collaboration with CYCLONES Discovery Center. Today we are going to focus, today is our second lesson for this year and we are going to look at tropical cyclones. Okay, grade 12s. Your teacher was supposed to taught you the content on tropical cyclones this past week. Tropical cyclones, we're going to look at the general characteristics, areas where they form, as well as the associated terms in the different parts of the world. What are the factors necessary for the formation? What are the stages that the tropical cyclone goes through during its development? We are going to look at associated weather patterns. We're going to look at the cross section through a tropical cyclone. We're going to look at the impact of the tropical cyclone on the environment and human activities. Some precautionary and management strategies. You will see how does a tropical cyclone look on a synoptic weather map, and then while you do that, you will look at weather symbols that we use, the eye of the cyclone, and then one recent tropical cyclone just to show you that whatever we teach you really exists. I'm also going to pay attention to the map work that was supposed to be taught this week, where we will look at contour lines, contour interval, height, and conventional signs. We will look at compass direction, true bearing, and then I'm specifically going to look at remote sensing. Remember, a satellite image is an example of remote sensing. Let's start. Before we start, some tips for this week. Ensure that you immediately revise the content that was taught that day. I would advise you to go over this video over this weekend and make sure that you know all the content. Search for past papers. You can find that on the internet.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
And there was a power failure, but here we go. Our study tips for this week is to ensure that you immediately revise the content that was taught in that specific day. I also would like to advise you to go through all the slides and this video so that you can familiarize yourself again with the content. Go through previous exam papers. You will find these exam papers on the internet. see if you can find as many as possible questions on tropical cyclones, and then you try to work those questions out. Listen to some video clips which covers this content. You will also see that this lesson of today consists of a few videos. Identify subtopics that you don't understand and ask your geography educator immediately for help. Draw mind maps, as we said last week as well, on the content that was taught this week. Let's start off with tropical cyclones, and here is an introduction video.
A tropical cyclone can be described as a relatively small, intensely developed low-pressure cell that takes place over warm ocean water, usually moving from east to west. There are three conditions required for these storms to strengthen into tropical cyclones. Firstly, a developing storm should maintain contact with warm waters of approximately 27 degrees Celsius to gather heat and energy. Secondly, consistent evaporation of seawater from the sea surface is necessary. And finally, a wind pattern near the ocean surface that spirals air inward. These conditions lead to a column of spiraling air with an intense low pressure in the center, creating thunderstorms while allowing air to warm further and rise higher into the atmosphere. Once a tropical cyclone is distinctly developed, it forms a clear structure which looks like a hole when seen from above. This hole is called the eye, and around the eye is the eye wall, which is where most destructive conditions are found. These conditions include severe storms and strong destructive winds of up to 200 kilometers per hour. A mature tropical cyclone will last as long as these atmospheric and oceanic conditions remain favorable. These conditions are: the storm should still be in contact with warm ocean water. This can last as long as 7 days. Once a tropical cyclone moves over land, it loses its source of energy and momentum and then begins to disappear, which meteorologists refer to as dissipating. In the South Indian Ocean, they are referred to as tropical cyclones, such as the one Dineo. And over the United States, they are called hurricanes, while in Southeast Asia, in places such as India and Japan, they are referred to as typhoons. In Australia, these storms are called willy-willies. They are further given individual names in alphabetical order. The first, for example, would have been called Abela. Bransby, Carlos, and Dineo are other names that are given to storms. The effects of such storms can be devastating, as floods may destroy agricultural land and cattle, infrastructure, and also cause deaths as a result of drowning. Strong winds associated with these storms can uproot trees, topple buildings, and cause storm surges along the affected coastal areas.
Let's start with the general characteristics of tropical cyclones, and you will see that some of these characteristics we've showed you in the video that was showing just now. General characteristics: it's an intense low pressure system with atmospheric pressure below 1000 hectopascal in the center. Intense low pressure, as the video said. It occurs late summer and autumn over warm tropical oceans. Remember, where's the tropics? It's around the equator, so it needs warm water. Then, because it's a low pressure system, we have clockwise movement of air in the southern hemisphere. Remember, in the northern hemisphere, it will just be the opposite. It's got a steep pressure gradient which increases the wind speed. These winds can blow as fast as 300 kilometers per hour. It moves from west to east. Why? Because it moves within the tropical easterlies. It's the tropical easterly wind belt that drives these tropical cyclones to move from east. It's actually east to west, not west. It's just my mistake there. It moves from east to west. from east to west. A mid-latitude cyclone moved from west to east. The eye developed in the center of a low pressure. We have high cumulonimbus clouds, which forms the eye wall, and then because of this cumulonimbus cloud, we all know cumulonimbus clouds are associated with heavy rain, hail, storm surges, and hurricane winds. They get names in alphabetical order, as the video just explained now, and then tropical cyclones affect the east coast of continent, mostly on the east coast. They developed over the ocean, but it dies out over land. Why? Because there is lots of friction over the land. It wants a smooth surface, and over the land there is a lack of infrastructure. Where does tropical cyclones form? And as I said in the video, they have certain terms in different parts of the world. So there is my map of the world. You'll see here in Asia it's called typhoons, and there it occurs between April to Jan. In the Indian Ocean we call it tropical cyclones. It's the same thing, we just call it a tropical cyclone. South America, they also talk about the tropical cyclone, and in Australia they also call it a tropical cyclone. But in America they call it a hurricane. I said to you previously it affects the east coast of continent, so you can see there it occurs there, east coast here, east coast there, east coast there, east coast there. So it affects the east coast of continent. Now there's the equator, it's the tropics. It does not, you will see later, it does not occur between 0 and 5 degrees north and south of the equator. It only develops from 5 degrees north and 5 degrees south. Which are the factors necessary for the formation? It needs to develop at 5 degrees north and south of the equator. Why? Because at the equator we have a weak Coriolis force, and the tropical cyclones need the force of the Coriolis force to move. The ocean must be warmer than 26.5 degrees Celsius. That means the minimum temperatures for a tropical cyclone to develop is 26.5 degrees. The warmer water has a high evaporation rate to feed this low pressure system. It developed over the tropical oceans. Now we can ask you, why the tropical oceans? Because I can always say why. There's less friction and it wants a smooth surface. So for every factor there's a reason. It needs hot moisture air. Why? Hot air rises. That makes the air unstable and it's going to rise. So a tropical cyclone requires hot moisture air. Unstable air will result in condensation, and condensation releases latent heat into the atmosphere, which provides more energy. So the bigger the condensation, or the stronger the condensation is, the more latent heat will be released, and that will give the tropical cyclone its energy to move. On the surface we have convergence. Remember, it's a low pressure, air converge and then it starts rising. So the surface air converge. When convergence takes place, air rises and it converges at the low pressure system here in the middle, in the center. In the upper air we have divergence. more moisture air drawn into the system at the surface as the air diverges in the upper air. So I have surface convergency with the low pressure, air rises, and in the upper air I have divergency of air. An intense low pressure cell is enhanced by the tropical jet stream in the upper air because of stronger surface convergency, convection, and upper air divergency. So my low pressure on the surface is enhanced, it becomes stronger because of tropical jet streams in the upper air. It needs the Coriolis force to cause spiraling winds. The deflection of air, remember the Coriolis force is responsible for the deflection of air. This deflection of air results in the clockwise circulation in the southern hemisphere. Remember, in the northern hemisphere it will just be the opposite. What are the stages of development of a tropical cyclone? It starts with the initial stage. What do I have in the initial stage? I have convergency of air towards a low pressure. So I have the low pressure. Now I have air flowing, convergency, they flowing in. It creates a vortex. Air pressure still is at 1002 hectopascal, and the wind speed is not that fast, it's around about 60 kilometers per hour. So there you can see your low pressure in the middle. I can see the clockwise rotation of air. You can see here isobars. Remember, the closer the isobars, the stronger the wind. But I know it's the initial stage because my atmospheric pressure is still 1002 hectopascal. And there's just a three-dimensional diagram to show you. I've got water of 26, actually 26.5 degrees. Air starts to rise, and here convergence. You can see clouds start to form. The second stage is the development stage. Now my storm is going to intensify. Why? Air continues to converge and it rises in the low pressure center. Divergency takes place in the upper air. So if I have the surface, I'm going to draw it again. There's my low pressure. Air converts, it starts to rise, and in the upper air, there high up in the air, I have divergency and convergency on the upper surface. The air pressure now is going to start drop below 990 hectopascal. Air pressure drops below 990 hectopascal. Wind increases to 120 kilometers per hour, and the eye forms in the center of the low pressure, like the video explained to us. Now, because of this rising of air, we have huge cumulonimbus clouds which forms the eye wall around the eye. The air swirls to form a vortex. In the middle is the vortex. The mature stage is where the storm reaches its maximum intensity. The pressure now drops below 950 hectopascal. If they give you a diagram or a map of a tropical cyclone and they ask you in which stage of development it is, the first thing you look at is you look at the middle of the low pressure and try to identify what is the air pressure. The wind speed now exceeds 180 kilometers per hour. Remember the initial stage, it was 60 kilometers per hour. Now the wind starts to exceed 180 kilometers per hour. We have a fully developed eye. You can see the eye clearly, and in that eye we have clear conditions. We have no clouds in the eye because air sinks there and it heats up adiabatically. Your vortex is now well developed, and this tropical cyclone is diameter-wise more or less 600 kilometers. We have torrential rain, thunder and lightning in the mature stage. And there you will see the symbol. Look at the clockwise rotation now. There's 974, 972, so this one will be 970. So you can see it's at less than 900, or it's going to for 950, but it's more or less 950 hectopascal. You can see here where the isobars are close to one another. It's this part where the wind is at its strongest. Your isobars are close to each other. And there you can see your three-dimensional diagram. This white is the cumulonimbus clouds, and you can see how quick the swirling effect is in that diagram. Dissipating stage, air cools down. When is it going to disappear? When we enter the temperate latitudes. That is when it starts moving to the 30 degrees, 40 degrees latitude lines. Air is going to cool down in those areas. So a tropical cyclone don't want cold air. Cooler air flows into the cyclone, and that's going to cause an increase in pressure. Then it's not a low pressure anymore. When it's moving inland, it is going to start moving over the land. It will be cut off from the moisture. That means not over the ocean anymore. And I will have surface friction that will slow down. And that's one of the reasons why a tropical cyclone dies as it moves over land. So there is my dissipating stage. How do I know it? You can confuse this with the initial stage, but then you have to look latitude-wise, where does the low pressure lie? What are the associated weather patterns of a tropical cyclone? So you will see there, remember the movement of a tropical cyclone is from east to west, and it influences the east coast of the continent. There in the middle is the eye, as we said. That side, the western side, is the storm approached, and that stage there is when the storm moves away. So this part, as the storm is approaching, will affect the coastline first. Then we will have the eye, and then we will have the other part of the tropical cyclone. First of all, if I look at number one is the area, it's the leading part of the tropical cyclone. Air pressure is dropping. My temperature is more or less 27 degrees Celsius. The wind speed is fast, and it's associated with light rain. We have light rain in that part. Here you can see air pressure starts dropping, temperatures drop a little bit, and the wind speed starts to increase. And we have light rain. Number two, it's that area over there. You can see just by looking at the diagram what will happen with the air pressure. There's the air pressure. Air pressure will start to drop. Look at the temperature. First drop, and then it increases again. Look at my wind speed. It becomes hurricane strength winds, and then I will have rain here because it's the area where the cumulonimbus clouds are forming. There you can see torrential rain occurs. Number 3 is air pressure. Remember, this is now in the eye. Air pressure is less than 950 hectopascal. Temperature rises to 28 degrees Celsius. Why? Due to adiabatic heating. The wind speed is calm in the eye. There is no wind. I have clear skies and I have no rain. It's dead quiet in the eye. 4 is air pressure starts rising again. Look at my air pressure. There it starts rising again. But low 27 degrees temperatures. There's my temperatures. It's going to start increasing. I still have wind speed of hurricane strength, but I will have torrential rain or heavy rainfall. That's the legacy. Number 5 is when this tropical cyclone now is over, everything starts to normalize. You'll see there temperature, wind speed, air pressure, and it is gone. Now let's look at the cross section through a tropical cyclone. And there you can see the low pressure. There's the eye in the middle. Then I have my cumulonimbus clouds around the eye. You can see there it's causing rain. Remember, cumulonimbus cloud is associated with thunderstorms and lightning. Then I have my stratus clouds further out. Boys and girls, make sure that you will be able to draw a cross section of a tropical cyclone. Not only identified on the synoptic weather map, but also a cross section. And then lastly, high up in the air, we have cirrus clouds. What is the impact of a tropical cyclone on the environment? Impact on the environment, we have strong winds, which causes storm surges, which can cause a rapid rise in sea level. It will cause floods, and the salt water will destroy the agricultural crops. Flooding and a rising river levels because of the rain, which can cause mudslides and landslides. With that, it can cause damage to infrastructure. It can destroy ecosystems and biodiversity, and some of the livestock can drown. It will also damage sewage pipes, which can result in pollution. Look at this video of a tropical cyclone over an area. girls, I hope you have seen how the water level increased. Have you seen how it affected the trees? Have you even seen how it affected those telephone lines and those electricity poles? A storm surge now therefore is these waves that come in, sea level that rises, and then because the waves are like that, it's because of the strong winds that's driving those waves in there. What will be the impact of a tropical cyclone on human activities? For example, imagine you were in that position where this tropical cyclone is coming. Strong winds will damage and shatter windows, and it will rip off roofs. That is how strong these winds are. So if you have a house, it might be that the winds will shatter the windows. It might be possible that it can rip off the roof, then you don't have a roof. Infrastructure will be damaged. Why? Roads and bridges were washed away. And now remember, it's going to become an economic factor, because after the storm, money will have to be spent to repair the roads and the bridges. You also saw in the video those poles and those cables will be damaged. People will lose their houses. Remember now, the windows can break and the roofs can blow off, so eventually you don't have a home. You are homeless. There's also the possibility of water pipes which will be damaged, and that means there's no fresh water. People will not be able to drink water, and you can just imagine what will happen if people will not be able to drink water. The wind and the water can damage power lines. That means they are without electricity. No light, no cooking, nothing can happen. People are power. You saw how strong those winds are on those poles. There's the possibility of death and injuries of people, but not only people, also animals. Why or how? The wind that is very strong, there are lots of floods, all that tons of water, and then those storm surges is those big waves that's going to flood the coastal areas. When there's people and these floods, you saw now how quick the water level were rising, and that will drown people that are in that area. There will be starvation due to lack of food. Remember, even shops can be flooded, and the shop might not be able to supply the people with food. And if the shops don't have food, people will starve. They don't have food to eat. There's also the possibility of the outbreak of diseases like cholera and typhoid, etc. These are all possibilities of diseases that can break out. This will put huge financial strain on families, as some of them will have to rebuild everything. They will have to rebuild the house. They will have to buy furniture again. And that's going to cause a lot of financial strain. A subsistence farmer that farms for himself and his family, he might lose everything. And then he's also without any food, which will lead to starvation. If we have fishermen or humans catching fish, the swell of those waves are very dangerous. And if they were there on the coastline, there's the possibility of drowning. Obviously, it will have also an impact on the economy. The floods will decrease the agricultural production. That means the people who's working on those farms might be unemployed. The floods or the hurricanes force winds that can damage the infrastructure, and that means the government has to spend money to repair that infrastructure. Floods restrict the accessibility to tourist attractions, which can affect tourism. We have less production, less income to the area. It will reduce the number of tourists because the whole place is damaged. And governments will have to spend a large amount of money to repair infrastructure and to support the families and the people that experience loss. Let's look at this video again. and girls, I hope you saw even tracks were upside down, and you see the trees, how strong. If that tree falls on you, it can kill people. It can kill the people inside the tracks and also outside. So I hope you have watched clearly what the impact can be of a tropical cyclone. Now what can you do? If the weather forecasters is warning people to say there's a tropical cyclone on its way, what precautionary and management strategies can we apply to reduce the effect of a tropical cyclone? In today's day and age, due to satellite images, they can monitor the development of a tropical cyclone. They can see where it is, what is the path that they follow, and they can have more or less an idea which areas it will approach. Satellite tracking can monitor the development and the path by means of satellites. The satellites can see how this tropical cyclone develops, where it is and where it's on its way to. The satellite sensors can collect details, for example, rainfall rates. Sometimes you have these specific satellites that collect detail, and in this case they can see how heavy and how much amount of rain is that was falling. Nowadays we also have very advanced weather predictions and warning systems in order to so that people can prepare themselves for this tropical cyclone that's coming. Early warning and communication for people to prepare. Why do we want them to be prepared? Because we want to discourage the chaos that it's going to create. Evacuate low-lying areas. If you live in a low-lying area, pack your bags and leave that area as soon as possible. Why we want to protect the people in those low-lying areas against any floods. Ensure that the infrastructure, the roads and the bridges that you have are of a good quality and that it will be able to withstand this lots of rain and heavy strong winds. If you are a farmer, keep your livestock in barns. Protect your livestock against wind and rain. Take them to a covered area. People as such need to stay indoors. Don't go out because we can have flying debris. There's lots of wind. You saw how strong those winds are, and it's heavy rain. So wherever you are, you must stay indoors. Upgrade technology in less economic developed countries, so that they have the necessary technology to pick up the path of the tropical cyclone, but also to warn people on local news, send out messages, etc. Have good medical care, especially to reduce the outbreak of diseases. Know what the people can expect. Make sure you have enough medicine to give to the people for in case there is an outbreak of a disease. Have good emergency service that's well equipped. Your helicopters, emergency helicopters, your ambulance. Make sure that they have all the necessary equipment inside to assist people where necessary. Have local civic or emergency services well prepared to assist. I'm talking also about your fire brigade. I'm talking about ambulance services. I'm talking about doctors. I'm talking about medical people. Everybody should be well prepared. How does the synoptic weather map look on a satellite image and on a synoptic weather map? There you can see I have Geralda is the tropical cyclone over there. Look at the symbol. There's the symbol that tells me it's a tropical cyclone. There's Geralda. Question can be, how many tropical cyclones have there been before Geralda? You start counting on your alphabet. A1, B2, C3, D4, E5, 6, F7, G. So this is the 7th tropical cyclone for the season. Look at the isobar. Now these two areas that have circles around it, that is your active quadrant. It's the strongest part of the tropical cyclone. It's this front quadrant here. Why? The question now is, why is it the strongest area of the tropical cyclone? Because winds rotating around the storm center together with the winds moving the cyclone from west to east. So it's a combination of the rotating of air around the low pressure as well as the whole system that's moving from east to west. In the southern hemisphere, it's the forward left-hand quadrant that is the most dangerous one. I'm going to show you now a tropical cyclone on the 5th of January this year, which was Tropical Cyclone Alvaro. He approached Madagascar, just to show you that we're not talking nonsense. Tropical Cyclone Alvaro tells me it's the first tropical cyclone for the season, made landfall over the southwestern central coast of Madagascar. You all know Madagascar is an island east of South Africa, and he made that approach on the 1st of January, New Year. And it crossed the southern central region on the 2nd of January. It caused casualties and an increasing number of people were affected. According to the National Bureau of Risk and Disaster Management, 10 people died. More than 9,500 people have been relocated to 36 evacuation centers, which means Madagascar is a country that prepares for tropical cyclones. Almost 26,000 people are affected, 241 settlements have been destroyed, and 426 houses were damaged. And then look there, 15 schools as well. On the 1st and the 2nd of January this year, it reaches its mature stage on the 5th of January. For the next 24 hours, light to moderated rain with isolated thunderstorms is expected across the northern, eastern and southeastern parts of Madagascar. Now listen to this warning.
Thank you very much for joining me on Earth QC, and a happy new year. Watching this, not such happy news with the system moving in. A severe tropical storm, Alvaro. This is the first one of the season. This is moving into Madagascar right now, and you see these brighter colors on the satellite. When you see the brighter colors, that means taller clouds in that, heavier rain, really gusty winds with that will be sliding in. The worst weather in Madagascar happening now and over the next 12 hours, but the next couple days, some of that rain will continue as it moves west to east. So here it is again, working in now. The impact's already being felt, especially central and southern Madagascar, and then as this moves across over the next 24 to 36 hours, we'll see some of that rain sliding across into our eastern zones and then eventually pulling into the open water. So here's South Africa, Botswana here, Zimbabwe, Mozambique. You see it again moving in now. The very heavy rain that we're seeing as we go over the next 12 hours through the night into tomorrow. But as we work our way into our Tuesday, heaviest rain against south central sections of Madagascar. And then eventually, as we get into later on our Tuesday into Wednesday, a lot of this moisture will start to work our way. But we're looking out for the flooding and, of course, the gusty winds on this. Elsewhere, watching out for a lot of heat. Botswana down through South Africa, Namibia, again, with the drier conditions, we've had some hotter weather. So you can see the core of it right here. A little bit of red and white showing up. That would be winds of about 50 to 70 miles per hour with higher gusts. 80 to 110 kilometers, but again, it could be as high as about 125 kilometers. Some of the gusts could be as high as about 75, 80 miles per hour, if not higher. But as this moves in over the next 12 hours, the winds will quickly subside, but the rain will still be with us. So breaking down the rain totals, and you see it again off the chart, this black shading, even this red shading, that means we're going to have some spots of 150 millimeters of rain or 6 inches of rain, but as much as 300 millimeters of rain or a foot of rain will be possible in some locations as this moves across. Again, not so much our northern zones, central, southern zones of Madagascar. That's where the worst weather will be. The gusty winds, the strong winds first, and then again, that rain event that will last the next couple days. So Alvaro, the first storm of the season, the impact's happening now. Heavy rain over the next 24 hours, and eventually that'll slide across and move to the east across the Indian Ocean as we work our way into our Wednesday. We'll keep a very close eye on the flooding, so I'll watch this. If you're in the area, leave those comments, keep me posted, and I hope you have a good rest of your day and a happy new year.
Not such a happy news for the people of Madagascar. This is just to show you that it's something that really exists. Now, boys and girls, I'm going to give you a worksheet. There's your map. And now I'm going to give you 3 minutes. Let's make it 5 minutes to complete these questions on this map, and then afterwards we're going to check the answers. But please stop, and then I'll give you 5 minutes to complete these questions. Okay, boys and girls, does the map show typical summer or winter conditions? So you must be able to use the information on the synoptic weather map to decide whether it's summer or winter. Now you do see a cold front here, but I also see tropical cyclone, and that needs to give you an indication. Draw the symbol present on the synoptic weather map to indicate the eye of the tropical cyclone. Remember, they can ask you to draw something. What evidence is there that indicates it's the mature stage? Remember what I said you need to look at? You look at the air pressure. Describe the weather in the eye of the cyclone. Describe. You must write sentences. How do a warm ocean contribute to the development of these cyclones? And suggest precautions the people of Maputo need to take within the next 24 hours. Remember, this tropical cyclone is approaching Maputo. Now you want to prepare the people. Let's see what your answers are. Also give yourself a mark. It shows summer conditions. Why? I have a tropical cyclone. Tropical cyclone telling me it is summer conditions. Draw the symbol. Here's the symbol. You can also just draw it like that. Remember, we want to see that and that. This is the indication. It is clockwise rotation of air. If it's the other way around, for example, this, that's the same one there. If it is something like this, it shows anticyclonic circulation. Question 143 was, what evidence suggests that it is in the mature stage? We have a very low air pressure in the center. You even named that. It's 992 hectopascal. You can see there the steep pressure gradient. There's 4 isobars surrounding the area of the low pressure. How do I know it's strong? They are very close to each other. That means a steep pressure gradient. That means I've got strong wind. And then there's a very clear eye that is available there that you can see. Not available, that is evident there. Just want to go another one back. Sorry. Describe the weather associated with the eye of the cyclone. I said that. Calm, no wind. There are no rain, no clouds. You can even say the pressure in the eye is extremely low and the surface temperature higher than 26.5 degrees Celsius. So any two of those 4, 2 times 2 is 4. Just quickly want to go back. Going to the front. Sorry for this. How do warm ocean contribute to the development of these cyclones? How does the warm wind? What does warm air do? It needs a warm air rises. So a tropical cyclone requires high levels of evaporation. If I have evaporation, I have condensation. During condensation, latent heat will originate, and these convection currents of warm, moisturizing air creates cumulonimbus clouds. And that is exactly what we need for a tropical cyclone to develop. The last question suggests precautionary measures the people of Maputo need to take within the following 24 hours. First of all, put evacuation plans in place to get people out of dangerous areas. So like your school have an evacuation plan where you need to move to in case of an emergency, you must have an evacuation plan to help these people to get out of those dangerous areas, most probably your low-lying areas. Then, as I said earlier on, there must be rescue teams, so that those rescue teams must now have the know-how to rescue people that are in flooded areas. For example, we can have helicopters that can pick up those people in the flooded areas. But you must have a rescue team, and that rescue team must know exactly what to do. Then, a good forecasting system is essential. What does the forecasting system do? This forecasting system will track the tropical cyclone, and it might predict the path so that the government can issue warning systems well in advance in the form of news, TV, radio, WhatsApp messages, social media like Facebook. Then, organize first aid kits. So a family can even have a first aid kit with the necessary plasters, with the necessary medicine for diseases. They must make sure that they have batteries, extra batteries for radios. Why do we want to have a radio? We want to listen to the news. We need to be informed about this tropical cyclone. We must have batteries for our lamps, as a tropical cyclone can damage the electricity lines. So we'll have to go over to lamps. Make sure the lamps has got batteries, or that those lamps are charged, and have extra torches with batteries if your lamps, because you don't know how long these areas will be damaged. Stock up food, preferably canned food. Have canned food in the cupboards, and you need to stock up because you don't know for how long you will be cut off from a shop, or how long the shop might have been damaged. And then have enough water supply. I also would say, buy liters and liters of water, or the government can have water trucks. Then a very, very good idea for a family is to place sandbags along their houses, and the government can have sandbags along the river or coastal areas, so that it can assist in reducing the impact of flooding. Those sandbags can prevent water to flow into your house, or for the water or the rivers to overflood. Erect wooden shutters on windows. Erect wooden shutters, as that will last longer. And educate people to stay away from the windows and doors during a storm. Remember, those windows and those doors can go open, and it can cause emergencies on people. People can get hurt because of the windows and the doors. So here you can see, boys and girls, everything. And I want you to look at a video like that one on a tropical cyclone and imagine you are in that area. What would you do to limit the impact of a tropical cyclone? Boys and girls, now we are going over to the map work part. Here we're going to look at contour lines, contour intervals, and height, and conventional signs. Now, what is a contour line? Remember, the map work part is where they can ask you to refer to a specific contour line, and then what is a contour line? It's a line on a topographic map. Now remember, we also have contour lines on orthophoto maps. What does these lines do? It joins places with the same height above sea level with each other. On a topographic map, these contour lines are normally brown. So there's your contour line. So everywhere at that one says more or less 740, I would say. So everywhere on this line, the area there is 740 meters above sea level. So these brown lines on a topographic map join places with the same height above sea level. A contour interval is the difference between two contour lines. So say for example, that is 740, that is 780. The difference between the two, if I go from that contour line to that contour line, it's in this case 20 meters, which tells me the contour interval is 20 meters. That means from the one contour line to the other one is 20 meters. But sometimes I can have, for example, an orthophoto map. And there you can see the one from the one contour line to the other one. It can be sometimes 5 meters or 10 meters. But most of the time, the contour interval is printed on the map. One side, on the topographic map side, it might be 20 meters, but also on the orthophoto map side. So first of all, when you receive your map in the map work task or the map work or the exam, first open up that map and try to find the words, the contour interval. Contour interval means the difference between two contour lines. How is height indicated on a map? First of all, by means of a trigonometrical station. Now I would like to invite you, when you ever is on the road again, try to be on the lookout for, sometimes it's also a cement base with a small pole and then it's got a symbol. Now it tells me on that specific point what is the height over there. Now on a map, this is how a trigonometrical station looks. It's got two numbers. The inclined one or the top one is the number of the beacon. The bottom number, that one, is the height of the beacon. Now this one is telling me trigonometrical station or trigonometrical beacon 74 is 653.4 meters above sea level. So that specific trig beacon 74, 653.4 meters above sea level. The second one is in the form of a spot height. So a spot height is a dot with a number, like in that case. And in this case, it says at that spot, at that dot, this area is 646 meters above sea level. Now, if they ask you to calculate from or to the trig beacon, I want you always to work to the apex of the trig beacon. You don't measure from there, you measure from the top there at the apex of the tropical cyclone. All measurements from there. And when we work on a spot height, you will measure from that dot. That dot is the starting or the ending point if you measure. Height, also a benchmark. Now a benchmark is where I have it. I just want to go back. For example, a benchmark tells me the height of the road. So if I have my road there, I will have an arrow, and that arrow will say 250 meters. That means on that specific point on that road, it is 250 meters above sea level. So a benchmark is the height of a road, indicated by an arrow and then a height of that specific area. Now we come to conventional signs. At the bottom of the map, you will find these symbols. Now, boys and girls, you don't have to study these symbols off by heart. You can just refer to the symbols. So it will tell you that, for example, if you have a black line and it just stops and it's doing that, that part is the tunnel, a railway tunnel. Or it will show you the W stands for a store. The P stands for a post office. A PS is the police station. Don't study this off by heart. It is on the map at the bottom. So if I ask you, or if the examiners ask you, to refer to the school in block D4, you must know that the school is a dot with an S. So make sure you know the symbols, or if you're not sure, go to that symbol on the map at the bottom. Now you will see we can divide the symbols into points, lines and polygons. So your national freeway or your national road, an arterial road which is the R21, or a main road which is red, or just any other secondary road. There's also an example of a benchmark, or any other road, or a hiking trail, or a railway line, or a power line for that matter, or a wall, or line symbol. It's represented lines on a map like that. I just want to go take you to these. A provincial boundary as well as the international boundary is also a line symbol. A pipeline is also a line symbol. And then very, very important is a perennial river. A perennial river or a non-perennial river, or no, not this one. Those two, that one and that one, is also a line symbol. Everything that's in the form of a line is a line symbol. They can ask you to refer to block A2 and give a line symbol. Then you must use your line symbol. If I just have something like this is a communication tower that looks like this, or if I have my trick beacon, or I have a grave, or I have the shop, those are point symbols. It's represented points on a map like a post office, a police station, or a shop. I'm going to come back and cancel their buildings because I'm going to say something about buildings later on. But my wind pump, my monument, my communication tower, even your marine beacon or your lighthouse are all examples of point symbols. Then we come to polygon. Polygon symbols are also area symbols. It indicates like, for example, a dam or a recreation park or a golf course. In this case, a cultivated land, an orchard and a vineyard. There's the recreation park. Or, by the way, a row of trees is also a line symbol, and the farm boundaries as well. These that cover areas. There's the dam. This is a built-up area, is also a polygon. A cemetery is also a polygon. A symbol on the map that indicates a specific area is referred to as polygons. So, we have lines, points, and polygons. They can go into the exam and ask you to give the attribute data, which is descriptive data, of the polygon feature in block A2. So you need to know what's a polygon feature, and you need to know attribute data is described. For example, this is spatial data. This is the spatial data, and this is the attribute data. Because the attribute data explains or describes to me what the spatial data is. This is just on the side. Now we come to compass direction. What is direction? It's expressed by using the points of a compass. North, east, south and west, as well as the points between them. Now I'm going to show you this. There are 16 cardinal points. I've got north, east, south and west are the major points. In between north and east I have northeast. In between south and east I have southeast. In between south and west I've got southwest, and in between west and north I have northwest. That brings me to 8. I originally had 4, now it's 8. Now between north and northeast I have north, northeast. I have north, northeast. Between northeast and east I'm going more to east, so it's east, northeast. Between southeast and east I've got east, southeast. Because south and southeast I've got south, southeast. Between south and southwest I've got south, southwest. Between west and southwest I've got west, southwest. Because between west and northwest I've got west, northwest. And between northwest and north I have north, northwest. You need to know all 16. They're not necessarily going to ask you in which direction is B from A. East. Very easy. When they ask you a question on direction, and they would ask you in which direction is Trick Beacon 27 from spot height 1 to 8. I always say to use the apex. So you draw your north-south line, your north-south, your east-west. Combine those two. Now you can see this east, there's south, there's southeast. So it tends to be your line must be more straight than mine. So the direction will be south, southeast. Remember to always use the apex. So at that point where you need to determine that direction from, immediately draw your north, south, east to west line so that you can divide it up again. True bearing. Boys and girls, step 1. True bearing is where you need to measure with your protractor. Step 1 is to note from where the bearing must be measured. They will ask you from A to B. From, I must start at A and B. Then you start by combining the 2 points with each other. Take a ruler, take a pencil, combine the 2, draw a line between the 2 points. That's step 2. Step 3 is place your protractor along the north-south line with the 0 at the top. There's your 0. There's your north-south line. At the point where you must measure from, you draw a north-south line. You put down your protractor and you read it off clockwise. You read the degrees off clockwise. Say for example, your point is here. You're not going to turn it around now. You first say from 0 to there is 180 degrees. Then you turn around your protractor so that it can look like this. Put it down and you say, for example, 69. So what will you do then? You will say 180 plus 67 is 2. So from there to there, it's 246 degrees. From there to there, it's more or less 130 degrees. So, boys and girls, make sure practice bearing by asking your teacher for a map and then put down your protractor and try to determine the area. Boys and girls, then we come to GIS, remote sensing. First of all, know this concept of part for 2 marks. What is remote sensing? It's a collection of data by a recording device that is not in direct contact with the area. Our keywords here is not in direct contact with the area. So it's a device where I record data, but I'm not in direct contact with the area or the object. For example, a satellite, an aircraft, a drone, or an aerial photo are ways in which we can capture remote sensing. There is your satellite, for example, and there you can also see other satellites taking pictures of the Earth. I'm busy with remote sensing. What are the advantages of remote sensing? We can cover a very large area. You can see, for example, a satellite can cover the Earth. It's taking photos of the Earth. You can access areas which you never ever can access with your foot or your body or with your feet or with a car. It's easy collection of data over a variety of scales and resolution. There's no limitation on the extent of information that can be gathered from a single remote sensed image. You take a satellite image, you can get so much information. You can process that data very quick and easy, and then you can further analyze it on a computer. It does not disturb the object or the area of interest. It's cheap and a fast method of collection data. And it's very easy to locate floods or forest fires that are spread over a large region, which makes it easier to plan a rescue mission easily and fast. What are the disadvantages though? It's an expensive method of analyzing, especially when you measure or analyze smaller areas. You know, drones are very expensive, satellites are very expensive. You need a special kind of training to analyze these images. Human errors may occur during the analyzing process. Sometimes different phenomena can be analyzed that may look the same during the measurements, and that can lead to classification errors. Sometimes large-scale engineering maps cannot be prepared from satellite data, which makes remote sensing data collection incomplete. How can remote sensing assist researchers? They can give an overview of the entire study area. It can allow a geologist to check and verify changes over time. The researchers don't have to be at the site to obtain the data. Weather conditions have limited influence on obtaining the data. Up-to-date data is easily and readily available. A geologist will have access to data that could not be easily reached by human beings. Data can be collected quickly. Safer to collect data from inaccessible places. Worksheet 2. Due to time, I'm just going to give you the 2 questions. Define the term remote sensing. Here you can see the ask again definition. And explain how remote sensing could assist in monitoring the environmental impact of tourists on Area M. That's now applicable to a map. What is remote sensing? Getting information about the Earth or an object from a distance. Or you can use the words without being in contact with the Earth or the object. Then number 2, how can it assist? A photograph can be taken over the specific periods to analyze the impact over time. Then they can use that information to regulate the number of tourists visiting the area to reduce the impact. Information can be used to determine the areas that are mostly affected or frequently affected, and put in place strategies that will focus on that area. Or the information can be used to educate tourists about the importance of being environmentally sensitive. Boys and girls, and this now is the end of today's lesson. Good luck for preparation. Remember to revise this topic we did this week, so that you can start off next week with your new topic. Enjoy your afternoon and goodbye.